Alright, today's lesson, the first part of it is I'm going to teach the idea of completing the square and quadratic formula. What I taught you last time was how to solve by factorization. Do you remember what the 4 different ways of factorizing were? Check your notes. Common factor, good. What was the next one? Yes? Difference of 2 squares, next one. Perfect squares, and then last one. Good. The point of, you could think of today's lesson as, what do we do if none of that works? So think of these 2 things as your last resort. Sometimes you have an expression that you cannot factorize using any of those things that you named. Let me show you why. Is there any common factor that's common to all 3 of these? Is x in -1? I can't remove x from it, so common factors is not going to work. Is this difference between 2 squares? There's 3 terms, so no. Is that a perfect square? Well, that's a square, that's another square, but that's a take, so that's not a perfect square either. And then your last resort so far was, what are the factors of 1? Well, what can I times together to get 1? 1. Is there any way that I'm ever going to get 6 by adding or subtracting 1? The best I can do is 0 or 2. Alright? So that is an illustration that everything we've taught you just failed on this. So the point is, these 2 methods are, what do I do if everything previously didn't work? One method you can try is called completing the square. Can you get these steps down? Because what I'm going to do is show both methods in one example. So just get these steps down, and you'll get an example later. I'll give you like 3 minutes. Can you get those 4 steps down? Move the constant term to the side that's opposite the x terms. Add the square of half the coefficient of x to both sides. Simplify both sides. One side is now a perfect square, and then 4. Factorize the perfect square side, then solve with null factorial. Get those steps down. The governor's here. It's kind of hoping that I had no lesson, so I could just say hello to her and just be like, yo, G, and then do a little handshake that the kids do, whatever it is. When my year 11s last year, they kept doing this to try to make it clap louder or something. No wonder you guys don't get any homework done. You're wasting so much time on silly things. It's not silly, is it? No. Yeah. Life changing. Life changing. So hopefully showing you, going through that little spiel with that x squared plus 6x take 1 equals 0 shows you that, yeah, we taught you a bunch of stuff that works a lot of the time. But what happens if it doesn't work, okay? Because we're in year 10 now, we can go to that step and go, okay, you can sort of handle next step. What's the next option? That's what completing the square is. I'll quickly go over quadratic formula because it's really important to get to the example. These steps don't really make sense until you see how it applies. So the last option, and if you do methods next year, which this test will very much decide whether you should be able to handle one or not, most year 11 and year 12 students that do methods will just use this method straight away, okay? Which is unfortunate because jumping straight to this last resort skips practicing skills that you develop by doing the previous options. What is the quadratic formula? Just like completing the square is used when other strategies fail, the quadratic formula is the last option to solve a quadratic equation. In your test, you're going to be asked to solve in specific ways. So I'll ask you, can you solve it by completing the square? Can you solve it by factorization, etc.? But if you forget all that or you'll freak out because people do weird things in tests all the time, you can solve it with this. and we'll give you some marks at least, okay? So just a repeat of that, in your test, we're going to ask you, can you solve this quadratic equation this particular way? Completing the square. But this, what I'm telling you now is this will always solve it. This will never fail, okay? So if all you can do is this, you'll at least get some marks for it, all right? So what is the quadratic formula? If I write my quadratic in this way, something x squared plus something else x plus a number equals 0. So is this written in that way? What's the number in front of x squared? Sorry? X squared. 1. Good. It's just not written. What's the number in front of x? 6. Is there a number by itself with no x on it? And does it equal 0? So that fits this. If I know what A, B, and C is, and it's written like that, I can plug all those numbers into the quadratic formula, and it gives me the answer. What is special about this? Notice, please, that this lets you solve quadratics that have a number in front of x squared. I have not shown you any way to solve a quadratic that has this. So that's maybe one of the reasons why you would choose to use this. Can you get this one down, please? And then I'll show you how to use these both. So until 10 past, so like 4 minutes from now, can you get this quadratic formula down? Also, a heads up, because you're preparing for that quadratic test, we'll be using your science lessons in week 9 formats. It's all combined from next week. Okay? Maths and science is all combined from next week. Minute, and then I'll do the examples, and then I'll shut my mouth for a bit, for an hour. Right, let's demonstrate. Let me approach this question as if I was a student who was new to this. Mr. T has taught me how to do common factors, factorization. Is there a common factor to all 3 of these terms? I can't remove x from 1, so that failed. I can't do that. Is this difference between 2 squares? There's 3 terms. Can't do that. Is this a perfect square? That's a negative. Can't do that. I can try sum and product. The only factors of 1 are 1, and I cannot get 6 by adding 1 and 1. I can only get 2 or 0 with that. So you've got these last 2 options. Let's show how you can answer this using completing the square. So let's apply this. Let's take these steps. Step 1, move the constant term to the side opposite the x terms. The constant term is a number. I need to move that negative 1 over to the other side. So what am I going to do to move that negative 1 to the right hand side? What's the opposite of taking 1 from something? Good. So this is going to become x squared plus 6x equals, add 1 to 0, 1. So have I just completed step 1? Have I moved the constant to the right hand side? That's a rhetorical question. Yes, I'm not going to teach it to you wrong. Alright? Step 2. Add this. This is the trickiest part because there's a lot of words there. But if you do terminology properly, and if I've explained it properly with proper English, you should be able to work it out. Add the square of half the coefficient of x. What does a coefficient mean?
The number next to x.
Good. And it's not the number next to x squared. The language specifically says the coefficient of x. What is the coefficient of x in that question?
6.
Good. What is half of it?
3.
And what is the, how do I write the square of 3? Just write 3 squared. So what are you going to do? You're going to add the square of half the coefficient of x to both sides. So this is going to look like x squared plus 6x. And what did he say? 3 squared is added to that side equals 1. Have I added 3 squared to both sides yet? So do it now. Plus, simplify both sides. So that's step 3, simplify both sides, which is, what does that mean? Work out what I can. X squared plus 6x. What is 3 squared? What's 3 times 3? 9 equals, what's 9 plus 1? Why is that useful? And this step shows you why it's called completing the square. Because what do you notice about the left-hand side now? It's a... Yes, it's a perfect square. It didn't used to be. But when I did all this business, now this is a perfect square. That'll factorize to x plus 3 all squared is equal to 10. Now what? What's the opposite of squaring something? Square root. So now, because you're in year 10, you acknowledge that it's plus or minus the square root of 10. I don't want to know what x plus 3 is. I want to know what x is. So how do I get rid of that plus 3 on the left-hand side? Take it away. So your final answer is x is equal to negative 3 plus or minus root 10. Why do I leave it as root 10? If you go onto your calculator and work out the square root of 10, it's not a nice number. It's just all decimals, okay? Can you get that example down, please? That's how you use completing the square. And then I'll finish off with using quadratic formula, and I'll shut my mouth for an hour. It's very difficult. Difficult to do that. Can I get a show of hands who selected 10 extension next semester?
I didn't get it.
Huh?
I didn't get it because I had a different thing on.
Yeah, it depends on your subject. Yeah, this gives me.
I'm assuming we do a unit of that, of this in...
No, it's a little, this little extension just applies because some of your book simplifies those roots, but we're not supposed to teach that until 10 extension. But it's quite easy. Can you get that example for completing the square down, please? I'll give you a couple more minutes, and then I'll do quadratic formula. Realize the irony, I'm still talking. I said I would shut my mouth for an hour.
You said you shut your mouth once you did quadratic formula, yeah?
Yeah, but still. Yep. Alright, let me quickly show quadratic formula then. So what did I say, quadratic formula? The quadratic has to be written in the form like this. Has to equal 0. Is it already written like that? Yeah, so I'll rewrite it anyway. X squared plus 6x take 1 equals nothing. In that situation, what is A? What's the number in front of x squared? 1. What is the number in front of x? B. 6. And what number is C? What is that constant? What kind of a 1 is it? Negative 1. Okay? So the way that you work this out isn't even doing all maths and everything, it's determining what number is sitting in front of these. And now you apply quadratic formula. So x is, I'm going to rewrite it here so it's clear to you how it fills in. B squared take 4ac over 2a. So we can start filling in the blanks. What did you just tell me b was? 6. So it's negative of that, negative 6, plus or minus root. It's b again, but it's squared. So I'm going to write 6 squared. Take 4 times by a. What did you just tell me a was? 1. What did you just tell me c was?
1. Oh, no, 1.
Be careful with that. It actually applies. And 2, what did you tell me a was again? 1. See how with quadratic formula it is, remember, have that on your cheat sheet, write it in that form, and just plug in the a, the b, and the c. Now, the only problem is you need to remember your bed mass, and if you stuff that up and your negative numbers, you'll still get it wrong. Okay? X is equal to negative 6 plus or minus. What is 6 squared?
36.
36. What kind of a 4 is this? Negative 4 times by 1 is? Negative 4. And then I times negative 4 by negative 1, that would be?
4.
Good. So 36 plus 4 over, what's 2 times by 1? 2. Almost there. Negative 6 plus or minus, what's 36 plus 4? 40 over 2. At this year level, we will accept this. In your test coming up, we will take this answer. Can you get that example down, please? And then I need to quickly do this extension. This will be a little head start for the extension maths kids, because you're only actually supposed to learn about this after. I need to teach this because your 13E5, there's some questions where the book simplifies the root, and then they won't know how to handle it. I can quickly teach you. So a couple of minutes for that example. You okay? You need a pen? No. I can't say it. You're knocking something. You need. All right. Why do I need to say we will take this answer? Let me explain. This is a little extension for you. Okay. This is a quick lesson on simplifying roots. Why? Why do we need to do that? Because normally you're only taught how to simplify this, root 40, if you do extension maths. Extension maths at this school is only offered in semester 2 of year 10. Okay? But, bro, you can quite quickly teach it to you. And the reason why it's applicable is student A here asked me a question. It's like, why is my answer wrong? We did everything you did. Because the book simplifies this. Okay? Your answer's still right, it just wasn't simplified. So the rule is this, that you would learn in extension maths. If I have the root of any number that's like a product of something, I times a couple of numbers together to get the number, I can break it up into root that and root that. I can break it up into all the factors as the roots. Why is that applicable? If you break a root down into its factors as roots, you can simplify any that are square numbers. So how does that apply here? The book, if you answer this question in your book, that's not what your answer is going to look like. Okay? But the reason why is because the book simplifies this. What factors are there of 40? What numbers can I times together to get 40?
2 and 20.
Yeah, so that could be 2 times by 20. What else? 4 and 10. Anything else?
5 and 8.
Anything else?
1 and 40.
Yep. That's about it. But which one of those pairs involves a square number that's not 1?
4 and 10.
Good. This? 4 times by 10, do you agree, is equal to 40? Now, according to that rule, how could I rewrite this? Root 4 times by root 10. What is the square root of 4? 2. So that can simplify to this. Okay? I'm telling you, you don't need to worry about it. You can stop here at year 10, but you're Ignite, and you're always going to question why is my answer different to what it says in the back of the book? I don't want you to lose trust. I don't want to be that teacher we don't want to be that teacher that goes, oh, don't worry about it, because you're Ignite, you're going to worry about it. So we explain. This is to build trust there. So now, if you were to answer that in the back of the book, this would go x equals -6 plus or minus. What do we just say root 40 you could simplify to? 2 root 10. That's all divided by 2. What's -6 divided by 2? -3. And if I've got a 2 and a 2 on top, they cancel out. Plus or minus root 10. You do not need to have your answer like that, but it just will apply. You guys in the other class, when you do 13E, I think it's question 5, there'll be some where you can simplify it. In my book, that one, okay? I will finally shut my mouth now. Can you get that example down, please? And then I'll leave you alone until 20 past 10.